Good morning to all my YouTube viewers. In this video, I like to discuss about test paper 5. It has total 30 questions. Let us start the job. A boat which has a speed of 5 km per hour in still water crosses a river of width 1 kilometer along the shortest possible path in 15 minutes. The velocity of the river water in kilometer per hour is. Here, width of the river given, that is 1 kilometer. Speed of the boat is given 5 km per hour. It is on still water. Now, the question here is we have to find out velocity of the river water. In time frame is also fixed here, that is 15 minutes. Shortest possible path in 15 minutes. Let us see how we can do this job. Take a velocity v of the boat. We can consider velocity of the boat is v as it is shown in the figure. Here, this is width of the river, that is 1 kilometer. From here to here it is 1 kilometer. And direction of river current is this direction, that is u, kilometer per hour taken, as it is given both in terms of kilometer per hour. Same dimension has taken for river current. Now if V is here, it has two components. With respect to this river width, say angle is theta, so it has V cos theta as well as V sin theta. What is the purpose of V sin theta? To get shortest distance, this is the shortest distance between these 2 points. Now V cos theta will be responsible for this distance travel. And what about V sin theta? V sin theta will counter the river current, that is u. It will balance this river current. By this way we can solve this problem. V sin theta will be equal to u as it is negotiating the river current. V sin theta equal to u. And V cos theta into time, because V is constant here and theta is also constant as it is selected by the boatman. So T, velocity into time will give you distance travel. Here the least distance d. Now from here we can, time is given, velocity of the boat is given, and distance, width of the river is known. So all parameters are known other than theta. Theta is the decision to be decided by the boatman. That means cos theta will be 4 by 5 will come. After simplification it is 4 by 5. Draw a simple right angle triangle, base over hypotenuse, that is 4 by 5, you can see. Then perpendicular will be 3. Now equation 1 is here where u is present. U we can find out from V sin theta. Sin theta available now, that is 3 by 5, and V is already given 5. So after putting all, we can get 5 into 3 by 5 will give 3 km per hour. That means velocity of the river current is 3 kilometer per hour. It is given here. You can see in choice number B, it is given in terms of kilometer per hour. Okay. Next job. A planet is at an average distance small d from the sun, and its average surface temperature is capital T. This is distance between sun and planet is small d, and temperature of the planet is capital T. Assume that the planet receives energy only from the sun, no other source is there, and losses energy only through radiation from the surface of the planet. Neglect atmospheric effect. When it will pass through atmosphere, some losses will be there, it is neglected here. Now there is a relation given, T proportional to d to the power minus small n. The value of small n we have to find out. Now energy received from sun, say energy which is coming out from sun is say P, then this energy spreads all over the universe from the sun to all the planets. So the very small portion of the energy power will receive by the planet, and we have to find out how much energy can receive by the planet. That is first job. Let us see this diagram. You can see this is sun, and this distance is small d between sun center and the planet center, that is small d. And from sun you can see it radiates out energy in all possible direction, I mean all through the surface area, that is 4 pi r square, 4 pi d square, d is the distance between. Now very small amount of energy is coming on this, and that we can assume that 50% of the planet's surface will receive this energy. That means cross section area we can take pi, capital R is the radius of the planet, pi r square will be the amount of. Now energy or power received by the planet will be P dash. That is how much? Part of it, that is total energy power generated by the sun divided by pi d square. That will be the per unit area, whatever amount of power coming out from the sun, into this cross section area of the planet. Very small here, that is pi big R square. That with respect to this distance, this is very very small. So pi r square we have to take only the cross section area as it is far away from the sun. Now this cancels, pi cancels, expression will be P r square by 4d square. This type of expression will be available. Now see how we can solve this job. As it is understood that part of the energy, that is P divided by 4 pi d square into pi r square amount of power is received by the planet. And what happens to the planet? Planet radiates out energy losses by the planet. That will be how much? Now from Stephen's law we can say power, that is this one, E into 4 pi r square. This is the amount. Now power here is sigma Boltzmann constant, that is E emissivity T to the power 4 into this pi r bigger square will be the amount of energy radiate out from the planet. That is the expression here. Now here temperature of the planet was given T to the power T, temperature was T. Now from Stephen's law, as we are using Stephen's law to radiate out, so sigma small e 4 pi bigger square into T to the power 4 will be the expression for releasing energy from the planet. And there is a thermal balance, thermal equilibrium will be between receiving energy and the loss of energy. And then energy lost by the planet and energy received by the planet will be equal. Now equalizing these two thermal equilibrium condition, then sigma T to the power 4 pi bigger square into E small e emissivity. Now that is equal to P divided by 4 pi d square into pi r square. From here we can simplify because only T and D is variable here. Rest all is constant. Sigma 4 pi r square small e P 4 pi here r square. Now all these are constant. Now we can write T to the power 4 equal proportional to 1 by D to the power square. Now as we are interested about T, proportional to D to the power minus half will come. That means N will be, as it is given here, you can see the expression which is given here, that is T to the power T proportional to D to the power minus N. So that means minus N equal to minus half. So we will get minus half and power is here D to the power minus half and N minus N equal to this one. So N will be plus half. That is that final expression. N will be plus half will come. So answer here given that is plus half and that is given in C. C will be the answer. Now come to next job. You can see job number 3, there is a diagram given on glass prism placed in this fashion as it is given. A glass prism of refractive index 1.5 is immersed in water where refractive index of water is 4/3. The light beam, a light beam incident normally on the face AB is totally reflected to reach on the face BC. I mean, the ray will fall on this, and as it is falling perpendicular to this surface, so ray will proceed into the prism without obstruction. Only there will be a phase difference. Now, as it is entering into this, thereafter it will fall on the AC at an angle, some angle theta, and that we have to see what should be the angle. That if you draw perpendicular from AC, you will get some incident angle will be there. Thereafter, it needs to get totally reflected. Total internal reflection is required. Then only it can that ray can come to BC. It can cross BC. That is the question here. You can see a glass prism or reflected 1.5 immersed in water, a light beam incident normally on the face AB is totally reflected to reach on the face BC. If there are few conditions given, we have to see which condition matching. Let us see how we can proceed. Here, this is the diagram. Ray will fall here. Thereafter, just draw a perpendicular from AC face and there will be an angle of incidence. This angle may be this angle you can say for total internal reflection it has to be greater than theta suffix c. Theta suffix c is the critical angle. For just to get total internal reflection, that is theta c, the minimum requirement is theta c. If it is more than theta c, it can easily without doubt it will reflect, just laws of reflections will be applicable here. Now let us come here how to do this job. Now as data are given, 1.5 for glass and mu for water is 4/3. Now as it is being told that the ray will straight enter and it enter into this glass, though it is entering here, you see liquid is there, liquid is not here, it is rays just entering into the glass up to this. Thereafter refraction will take place between this water and glass, and we can use as total internal reflection TIR, you know that we can use Snell's law. Our requirement theta should be greater than theta c, that is our basic requirement. Now where from light is coming for internal reflection, light is coming from glass, mu glass into sine of whatever angle of incidence, theta c we have taken because the minimum requirement, that will be equal to mu water, because thereafter water is here, sine of this graze, if it grazes, even it is internal reflection taking place. I mean ray is coming from here, then it grazing AC surface. That means refracted angle will be 90 degree. If you say it is coming here, I mean this angle, if you draw this line up to this angle is 90 degree. That is the minimum requirement, sin 90. Now from here sin theta c will come, water refractive index of water over refractive index of glass, and this sin 90 is one here, and put it and will get 8/9. That means angle theta as we know greater than theta c hona chahiye, will give total internal reflection. So sin theta has to be greater than equal to 8/9. I mean if it is theta c, 8/9. If it is greater than theta c, definitely this greater than is applicable here. It should be that value of sin theta will be greater than 8/9. I mean for this particular angle, this critical angle will be available, and more than that angle you will get it, total internal reflection. That is the point here. Now here answer is A. A is giving correct answer, this one. Sin theta greater than equal to 8/9. Simple job. Next come to a rod of length L lies along the axis of a concave mirror of focal length F. The near end of the rod is at a distance, near end of the rod is at a distance L greater than F. I mean this is the condition given here, that L is greater than F, that the near end, that means it has to place in such a manner that it should be beyond, away from focal length. That is the meaning here. L, a distance L greater than F from the mirror, its image will have a length, you have to see. That means here we can take in this way. This condition to be noted here, L is greater than F. So let us see how you can do this. This is the diagram here, concave mirror, and focal length is this one, from here to here this is focal length. Say this position is 1, this position is 2. Now say it is very close to focal length, then it will be easier for us to handle, but not necessary. Sorry, this length is L. Length of the object is L. Okay. Now you have placed away from focus. I mean somewhere here, and this distance is L. This distance L, which is greater than f. That is the meaning of this question here. What is given here? You can see the rod of length L lies along the axis of a concave mirror of focal length f. The near end of the rod is at a distance L, which is greater than f from the mirror. That is the meaning. Language is very carefully have to handle. Now 1 by say initial for this position, there will be a image somewhere here. Image will be available on the axis. Now say that is V1. 1 by, we know 1 by V plus 1 by U equal to 1 by F for concave mirror. Now all are negative, you know that for this particular arrangement L is will be this side. I mean will take negative. Similarly V will form negative, and F, all this formula will be this one, 1 by V1 plus 1 by L 1 by U equal to 1 by F. Instead of U, we will put L. Now from here V1 will be available like this. LF, LCM, then L minus F will come in the numerator. Just it will be reciprocal of that, LF divided by L minus F. That is the first point's image position with respect to pole of the mirror. From here, this image where it will form, that distance is this one. Okay. Next, the same fashion you can do position 2, 1 by V2 plus 1 by distance has become twice L. This length of the object is L, and it is placed L distance away from the pole, so it will become twice L. Here it was L, you can see. Now here it is twice L. Now V2 will be available in the same fashion, twice L F over twice L minus F. Now as we need to get V1 minus V2 or V2 minus V1, whether it comes negative or positive, take mod value, we will get the actual absolute value. That will be subtract, suppose this one minus this one. You will get expression like this, LF, simplify, then you come here. You will get, in the denominator you will see L minus F is there within bracket, then twice L minus F is there, twice L minus F. In the numerator you will be getting L F square, and this expression is the image length, I mean V1 minus V2 or V2 minus V1. If negative comes, take mod. That will be the image distance for this particular arrangement, that is L F square by L minus F within bracket twice L minus F. You can see it here. Here, which one? L F square divided by L minus F twice L minus F. I think this one. L F twice L minus F. Both the expression looks same. No, and this is L square F. This one will be the answer. Answer will be A. L F square. Here it is L square F. So it cannot be. This one is the answer. Answer A. L square is not the correct one. Now come to next job, that is job number 5. Here you can see between two infinitely long wires having linear charge densities lambda and minus lambda, there are 2 points A and B as shown in the figure. The amount of work done by the electric field in moving a point charge Q0 from A to B. I mean, this is one wire, lambda 1 is the charge density, another is lambda 2. Now from A to B, Q naught charge moved from A to B. How much work done will be there? If it moves from A to B, what will be the amount of work done? That is our objective here, according to the question. Now this, we know that infinite charge, that is lambda charge density, linear charge density, we can find out electric field here. We know that this will give electric field away from the conductor, perpendicularly away from the conductor. I mean it will be along the direction AB. Now for this negative charge, on it will have a force, electric field or force, as the charge is Q naught positive, so it will have a force attraction. I mean it will be towards the wire, and if from positive wire it will be away, from negative wire it will be towards. So we know how to calculate electric field around an infinite wire, that is known with the help of Gauss law. We can do this. Let us see how we can proceed this job. As it is explained here, E1 will be towards AB direction. Similarly, E2 will be in the same direction, and distance between them is thrice A. From A to B, distance is A. Now, from Gauss law, we can solve this. That is, close integration E dot ds equal to Q by epsilon naught. Now, around this conductor, you can imagine one suitable cylinder, suitable Gaussian surface, that is 2 pi, perpendicular distance is A into height is L. That means curved surface area will be 2 pi A L. E dot this ds both acts in the same direction. Area vector radially outward as well as E vector also radially outward. So cos 0 will be there. So it is not shown here. That is E 2 pi A L is the total flux. That flux will be how much? We know Q by epsilon naught. How much charge is involved for a length of L length of cylinder? Linear charge density into L by epsilon naught. So both side L is there, so L will cancel fast. Then it will come lambda divided by 2 pi epsilon naught into A. That means lambda is constant, 2 pi epsilon naught is constant. Only variable is 1 by A. A will be the variable in this case. Now, as two wires are there, so resultant will be in the same direction. E1 plus E2, that means E resultant, that will be lambda by A. This is constant, plus lambda by again twice A, as it both acts in the same direction, so plus will be there. So the constant part taken out from here, lambda by 2 pi epsilon naught taken out. That means 1 by A can be replaced by 1 by x, because it will move from position A to B. Suppose any arbitrary distance x is there, so expression will change from A to this one, 1 by x plus 1 by total distance is thrice A minus x. That will be the single variable, that is x here. Now, as we are interested about work done, that is Q naught E as a function of x into dx, I mean this one into Q naught into dx. Here you can see dx is there, dx is already given individually here as well as here. So dx, this will give the amount of work done. Where from it will move? This charge is it will move from A to, because A to B, I mean it will move from A to twice A. B position is distance from the left side wire is twice A. Similarly, for the other one also A to twice A. Now here we have to do this integration. How to do? We know this 1 by x dx means ln 2, this divided by this ln 2a by a, so it will give you ln 2. And here if you take z, this one, you can take z equal to thrice a minus x, differentiate, instead of dx put dz, it will give minus, you can have a change of function, that means z will come here, so limit will accordingly you have to set. When a you will substitute here, it will be twice small a. When you will substitute here twice a, it will give small a. Now minus this thing will come, this is again same type of integration, ln upper limit by lower limit, it will give minus ln half. So you can bring 2 up in the numerator one by putting one minus sign on the power, so that minus will come in here and it will become plus. That means ln 2 plus ln 2 will come. In addition to that, the lambda by 2 pi epsilon naught in the outside. Now q is also there, q naught lambda 2 pi epsilon naught, this will be there into 2 ln 2. That will be the answer. 2 will get cancelled, final expression will be this one, q naught lambda by pi epsilon naught ln 2. Let us see where it is. I think in D it is there, lambda q naught lambda pi epsilon by pi epsilon naught ln 2. Here also you can see q naught lambda by pi epsilon naught ln 2. That matches. Now next job, number 6. A uniform chain of length bigel and mass bgm is lying on a smooth table, and 1/3 of its length is hanging vertically down over the edge of the table. If small g is the acceleration due to gravity, the work done required to pull the hanging part of the chain on the table is. There are 4 choices. Now this is a simple job. How much hanging? 1/3 of the length. If bgm is for mass of the total chain, then per unit mass will be bgm by L into 1/3 length will be L by 3 into, that means m by 3 will come, and this portion of the chain to be lifted on the table. So there will be a gain in potential energy when it will be lifted. That will be how much? Mass is m by 3 into small g into h. How much height it will rise? If we take the cg of that hanging part, that will be L by 3 into half. I mean it will be L by 6. Multiplying all, we will get mgl by 18. And this will be the gain of potential energy. That will be done by an external force on the chain, and work done by that external agent will be mgl by 18. You can see this solution. This chain is lifted, 1/3 is hanging, a mass will be m by 3, and potential energy gain will be mgl by 18, and work done due to external agent will be external agent is required to lift this chain itself cannot go up, so that is to be noted. So mgl divided by 18 will come. Now come to next job. A person of mass, no, another job is this. Number 7. A flexible wire loop in the shape of a circle has a radius that grows linearly with time. There is a magnetic field perpendicular to the plane of the loop that has a magnitude inversely proportional to the distance from the center of the loop. B is a function of radius that is proportional to 1 by r. How does the EMF E vary with time? How it will vary? that has to see. Now you can see this diagram. This is a flexible rope. So R can increase its radius can increase along this direction. That will be dr. This thickness is dr. It can increase. Now, as it is understood that R is a function of time, so we can EMF, we know that minus d phi by dt. Here EMF will be minus d by dt, and for phi we know that b dot a, and here b is a b we can substitute it is in terms of radius. Already say b is inversely, where it is, you can see in the question, b is inversely proportional to 1 by r. So we can substitute by some constant k into k by r. This is constant, k is constant, into area, that is pi r square. Now after simplification, here we will get, it is a dot product, and this vector b and area vector both acts in the same direction. Area vector is perpendicular to the area, and b also in the same direction, so cos 0 will be there, so 1. Now here we will get k, pi k is a constant, and here r will be there left, that is r is a function of time. As time changes, r also increases here. Now EMF will be pi k is constant, dr is a function of time divided by dt. R will change with time. Now as it is understood that r is a function of t, and it is given in the question, that is it is linearly increases. That means r is a function of time, is some constant a into time. Linear equation, this is a linear equation, straight line equation. Now differentiating this, we will get a constant a, dr by dt will give constant. Substitute this one here, dr by dt, that will give a constant. That means pi constant, k also constant, a also constant. So EMF will generate in constant amount. Take the modulus value, that means a constant EMF will generate in this case. So our answer will be here D, E is constant. That will be the answer for this particular job. Next job 8. A person of mass 60 kg wants to lose 5 kg by going up and down in a 10-meter high stairs. Assume he burns twice as much fat while going up, then coming down. If 1 kg of fat is burnt on expending 7,000 kilocalories, 7,000 kilocalories, how many times must he go up and down to reduce his weight by 5 kg? You have to identify which answer is correct. Here important points are that 10-meter high stair, man has got 60 kg, wants to lose 5 kg. I mean he wants to be a 55 kg man. Now assume he burns twice as much fat while going up. When he is going up, he will lose double calories. Then coming down. That means we can start like this. Fat burns when he going up, say E. When he goes up, it is E. When he comes down, it will be E by 2 according to the question. When he goes up, it is E. When he comes down, it will be E by 2. Now total is 3E by 2. Now weight loss for 1 kg mass weight loss will be this one, 7,000 kilocalories. That means For 5 kg weight he wants to lose, that means 5 into 7,000 kilocalories. I mean 5 into 7 into 10 to the power 6. This kilo, 10 to the power 3. Again 3 zeros here, 10 to the power 6 will be here. That means 35 into 10 to the power 6 calories energy has to release. What to do? As for single, when he is the energy, when he goes up, that is mgh, that is m means 60 kg man, that g is 10 and height is 10 meters. So 6,000 calories will be losing when he goes up, only one way, that is up. Then when he will come down, another 3,000 kg will lose. So when he is going for the total cycle, just general equation you can design from here. Total energy loss for each cycle is how much? 3e by 2. Already I have shown here 3e by 2 for each cycle. Now 3e by 2 divided by 1 by 4.2. This is 3e by 2 joules. We have to convert in terms of calories. So it will be we have to divide this one by 4.2 joules per calorie. Joule will cancel, calorie will come here. So our expression what is available for single cycle, this amount of energy has to lose, calories has to lose. That means total amount of already known 35 into 10 to the power 6 amount of calories has to lose, divided by each cycle. Number of cycles will be, if we divide by this one, for each single cycle it is the amount to lose. Just divided by this we will get this simple calculation we have to do, and it will give us 16,333 number of cycles are needed to reduce 5 kg mass. That is the point, simple job. Now here answer you can see 16,334. D will be the answer. Now come to next job. Consider the spectral line resulting from the transition n equal to 2 to n equal to 1 in the atoms and ions given below. The shortest wavelength is produced by, we have to see which element going to give shortest wavelength. Hydrogen atom is given, deuterium atom is given, singly ionized helium, and doubly ionized helium. These 4 elements are given. We have to see which one is correct. We know that 1 by lambda, we know this formula. Wavelength for spectral emission, general formula is 1 by lambda equal to r z square within bracket 1 by n f square minus 1 by n I square. This is known to all of us. Now this r is Rydberg constant and z is atomic number. So we need to see here, this is fixed, this is 2, this is 1, that is constant, r is also constant. So 1 by lambda can be written proportional to z square. Seeing the atomic number, decision will be taken. So lambda will be proportional to 1 by z square. From here we can see that z is 1 for hydrogen atom and deuterium z is 2. For ionized helium, that is also 2, z is 2, hydrogen helium, you know the 2 atomic number. And for ionized lithium, hydrogen helium lithium is 3. So when z is 3, it will give the shortest wavelength. That is the meaning here. Shortest wavelength will be for element D, that is ionized lithium. 9, answer will be D, doubly ionized lithium. Now next job, number 10. The hypothetical experiment conducted to determine Young's modulus gave the formula y equal to cos theta t to the power x into tau divided by L cube. T, capital T is time period, tau is torque, L is length, then the value of x. We have to find out value of x. This type of thing we have to solve by dimensional formula. Let us see. Now you can see y equal to given like this, and y is a Young modulus, time period t, torque is tau, L is length. Now Young modulus is stress by strain. Stress means M, you know that stress is force per unit area. That means ml t to the power minus 2, this one ml t to the power minus 2 divided by L square, it will give us m L to the power minus 1 t to the power minus 2. Okay, that is Young modulus, m L to the power minus 1 t to the power minus 2. Now you have to substitute here, because cos theta is the dimensionless quantity, because ratio of two sides. T is a time period, that means t to the power x will be there here, and tau is a torque is mL's force into displacement, that means ml square t to the power 2 minus 2 divided by here LQ is there, so divided by LQ. From here we can equalize with this one, with this. Now we will get this type of expression. This one is for Young modulus equal to this one. Now from left right solving, you can see it will give t to the power x minus 2, and this is will cancel, L to the power minus 1 cancels, t to the power minus 2. That means minus 2 will be x minus 2. That means x is coming 0. That means A will be the choice here. In the question it is given A will be the answer. You can check here. This is answer, A equal to 0. That means x is 0 here. Now next job 10. Here I like to discuss about this yesterday's video. I have given this 28. It is solution was little bit bigger. I like to explain this one so that student can without solving the problem straight cut can come down to answer. I like to explain once again. Let us see what was the question. Inside a long straight uniform wire of round cross section there is a long round cylindrical cavity whose axis is parallel to the axis of the wire and displaced from latter by a distance small d. If a direct current of density J flows along the wire, then magnetic field inside the cavity will be. We'll see answer once again. Now, logic to solve this problem, concept behind this is there is a cavity here in between this is a cross section of a cylindrical wire. That cavity means there is no current. First we will consider there is no cavity. The entire cross section has